Transformer interview questions and answers. Are you preparing for a transformer interview in electrical engineering? Whether you're a fresher or an experienced professional, understanding transformer fundamentals is absolutely essential. In this video, I'll walk you through the top 25 transformer interview questions and answers explained in a simple and practical way. Let's get started. 1. What is a transformer? A transformer is a static electrical device used to transfer electrical energy from one circuit to another through electromagnetic induction. It works on the principle of mutual induction between two windings, called primary and secondary. Transformers are mainly used to step up or step down voltage levels in power systems. Since it has no moving parts, it is highly efficient and reliable. Transformers are widely used in power generation, transmission, and distribution networks across industries and households. 2. What is the working principle of a transformer? A transformer works on the principle of electromagnetic induction discovered by Faraday. When alternating current flows through the primary winding, it produces a changing magnetic flux in the core. This changing magnetic field induces a voltage in the secondary winding. The amount of induced voltage depends on the turns ratio between primary and secondary coils. Without AC supply, a transformer cannot operate because constant current does not produce changing magnetic flux required for voltage induction. 3. What are the main parts of a transformer? The main parts of a transformer include the core, primary winding, secondary winding, insulation, tank, and cooling system. The core is usually made of laminated silicon steel sheets to reduce eddy current losses. The windings are copper or aluminum coils wound around the core. The tank contains insulating oil for cooling and insulation. Other components include bushings, conservator, breather, and tap changer. Each component plays a vital role in safe and efficient transformer operation. 4. What is turns ratio in a transformer? Turns ratio is the ratio of the number of turns in the primary winding to the number of turns in the secondary winding. It determines whether the transformer steps up or steps down voltage. If the secondary has more turns than the primary, it is a step-up transformer. If it has fewer turns, it is a step-down transformer. The voltage ratio is directly proportional to the turns ratio, while current ratio is inversely proportional. 5. What is the difference between step-up and step-down transformer? A step-up transformer increases voltage from primary to secondary while reducing current. It is commonly used at power generation stations to transmit electricity over long distances. A step-down transformer reduces voltage while increasing current and is used in distribution systems for homes and industries. The main difference lies in the turns ratio. Step-up transformers have more secondary turns, while step-down transformers have fewer secondary turns compared to primary winding. 6. What are transformer losses? Transformer losses are mainly divided into core losses and copper losses. Core losses include hysteresis loss and eddy current loss, which occur in the iron core. Copper losses occur due to resistance in windings when current flows. These losses reduce overall efficiency. Core losses are constant, while copper losses vary with load. Proper design, quality materials, and cooling systems help minimize these losses and improve transformer performance and lifespan. 7. What is efficiency of a transformer? Transformer efficiency is the ratio of output power to input power expressed as a percentage. Since transformers have no mechanical losses, their efficiency is very high, typically above 95%. Efficiency depends on copper losses and core losses. It is maximum when copper loss equals iron loss. High efficiency is important in power systems because transformers operate continuously, and even small losses can result in significant energy wastage over time. 8. What is voltage regulation in transformer? Voltage regulation refers to the change in secondary voltage from no load to full load conditions, expressed as a percentage of full load voltage. It indicates the ability of a transformer to maintain constant output voltage under varying loads. Lower voltage regulation means better performance. Voltage drops occur due to internal impedance of windings. Good transformer design aims to achieve minimal voltage regulation for stable and reliable power supply. 9. What is an ideal transformer? An ideal transformer is a theoretical transformer with no losses and 100% efficiency. It assumes no copper loss, no core loss, no leakage flux, and zero winding resistance. In an ideal transformer, input power equals output power. Although practical transformers are not ideal, the ideal model is used for understanding basic concepts and performing calculations. Real transformers are designed to operate as close as possible to ideal conditions. 10. What is a distribution transformer? A distribution transformer is used to reduce voltage from transmission levels to usable levels for consumers. It operates at lower voltages and is usually installed near residential or commercial areas. These transformers are designed for continuous operation and high efficiency at low loads. They typically have ratings below 200 kVA. Distribution transformers ensure safe and reliable electricity supply to homes, offices, and small industries. 11. What is a power transformer? A power transformer is used in transmission networks for stepping up or stepping down high voltages. It operates at high voltage levels and large capacities, typically above 200 kVA. Power transformers are designed for maximum efficiency at full load because they operate close to rated capacity. They are usually installed in power generation stations and substations. These transformers play a critical role in long-distance power transmission. 12. What is auto transformer? An auto transformer has a single winding that acts as both primary and secondary. Part of the winding is common to both circuits. It is smaller, cheaper, and more efficient compared to a two-winding transformer. However, it does not provide electrical isolation between input and output. Auto transformers are used in voltage regulation, motor starting, and where small voltage variations are required. They are widely used in industrial applications. 13. What is Buchholz relay? Buchholz relay is a protective device used in oil-filled transformers. It is installed between the main tank and conservator. It detects faults inside the transformer such as insulation failure or winding short circuits. When a fault occurs, gas is produced due to oil decomposition. The relay senses this gas and triggers an alarm or trip signal. It provides early fault detection and protects the transformer from severe damage. 14. What is transformer oil? Transformer oil is an insulating and cooling medium used in oil-filled transformers. It provides electrical insulation between internal components and dissipates heat generated during operation. The oil must have high dielectric strength and good thermal stability. It also prevents oxidation of internal parts. Regular testing of oil ensures proper performance. Transformer oil plays a crucial role in maintaining efficiency, insulation, and longevity of the transformer. 15. What is open circuit test? Open circuit test is performed to determine core losses and parameters of the transformer. In this test, the secondary winding is kept open, and rated voltage is applied to the primary. Since no load is connected, only a small current flows. The measured power mainly represents iron losses. This test helps calculate efficiency and equivalent circuit parameters without applying full load to the transformer. 16. What is short circuit test? Short circuit test is conducted to determine copper losses and impedance of a transformer. In this test, the secondary winding is short-circuited, and a reduced voltage is applied to the primary. The voltage is adjusted until rated current flows. Since applied voltage is low, core losses are negligible. The measured power represents copper losses. This test helps calculate regulation and efficiency under load conditions. 17. What is tap changer in transformer? A tap changer is a device used to adjust the output voltage of a transformer. It changes the number of turns in the winding to control voltage levels. Tap changers can be off-load or on-load types. On-load tap changers adjust voltage without interrupting supply. They are essential in maintaining stable voltage in power systems under varying load conditions. Tap changers improve voltage regulation and system reliability. 18. What is parallel operation of transformers? Parallel operation means connecting two or more transformers to supply a common load. This increases reliability and load sharing capacity. For successful parallel operation, transformers must have the same voltage ratio, polarity, phase sequence, and impedance. Proper load sharing prevents overloading. Parallel operation ensures continuous power supply during maintenance or failure of one transformer. It is widely used in substations and industrial setups. 19. What is transformer cooling methods? Transformer cooling methods remove heat generated during operation. Common cooling methods include air-natural, air-forced, oil-natural air-natural, and oil-forced air-forced systems. Cooling improves efficiency and prevents overheating. Large transformers use radiators, fans, and oil pumps for effective heat dissipation. Proper cooling increases transformer lifespan and maintains insulation quality. Selection depends on transformer rating and operating conditions. 20. What is polarity in transformer? Polarity in a transformer indicates the direction of induced voltage in primary and secondary windings. It is important when connecting transformers in parallel. There are two types: additive polarity and subtractive polarity. Correct polarity ensures proper voltage addition and prevents short circuits. Polarity is determined using a simple voltage test. Proper identification avoids serious damage during installation and operation. 21. What is hysteresis loss? Hysteresis loss occurs in the transformer core due to repeated magnetization and demagnetization of magnetic material. It depends on frequency and type of core material. Silicon steel is commonly used to reduce hysteresis loss. This loss appears as heat in the core. It is constant regardless of load. Proper material selection and design minimize hysteresis loss and improve transformer efficiency. 22. What is eddy current loss? Eddy current loss occurs when circulating currents are induced in the transformer core due to changing magnetic flux. These currents produce heat and reduce efficiency. To minimize this loss, the core is made of thin laminated sheets insulated from each other. Laminations restrict current flow and reduce heating. Eddy current loss increases with frequency and flux density. Proper core design significantly lowers this loss. 23. Why transformer rating is in kVA? Transformers are rated in kVA because losses depend on voltage and current, not on power factor. The transformer does not know the load power factor. It only handles voltage and current. Real power in kilowatt depends on power factor, which varies with load. Therefore, rating in kVA provides a universal measure of capacity. This standard rating ensures proper selection regardless of load type. 24. What is core type and shell type transformer? Core type transformer has windings placed around the core limbs, while shell type has the core surrounding the windings. In core type, the magnetic circuit is single, whereas in shell type, it is double magnetic circuit. Shell type provides better mechanical strength and reduced leakage flux. Both types are widely used depending on application requirements and design considerations. 25. What is leakage flux in transformer? Leakage flux is the portion of magnetic flux that does not link both primary and secondary windings. It flows outside the core path and reduces coupling efficiency. Leakage flux causes voltage drop and affects regulation. Although it cannot be completely eliminated, proper design and winding arrangement minimize its effects. Controlling leakage flux improves transformer performance and voltage stability. So that's it, the top 25 transformer interview questions and answers explained in a clear and simple way. If you found this video helpful, don't forget to like, share, and subscribe for more technical interview preparation content. Best of luck with your transformer interview. You've got this.